Hi Jaco, it's nice to meet you here at the congatec stand. I'd like you to just start by telling us a little bit about the products that congatec supplies and the sort of solutions you're helping to build, your customers to build.
Thank you, Stuart, and to have Elektor here. So I'm growing up with the Elektor magazine in my apprenticeship time, and it's great to have you also on the industrial side.
Thank you very much.
So we are here at the congatec booth at the Embedded World 22, and congatec has a very strong focus on embedded computing, especially on computer modules based on open standards. So congatec is one of the driving leader company to develop new open standard designs, to bring them into the world with other partners, with other market players, to make it very successful. And here we have a focus on the smaller computer on modules that we would like to show and introduce you with one example demonstration.
Super. So what sort of standardization is available for these computer modules?
So when we come from the smaller performance size and mechanical size, then we have the very well-known Q7 standard that we brought into the embedded world around 15 years ago. And we also have another one that's called the Smart Computer Module. And on both of these open standards, we have several processor versions on this very compact computer module. So you have a computer module where the processor is designed on, and you connect this on a carrier board, and together it's like one board, and this gives the chance to the customer, to the system integrator, to have a very strong focus on his final system, because he can design this carrier board around it, and we give him the computer module with the deep knowledge of the processor design, so he can focus on his end design.
So the modules themselves have this standardized interface, but what sort of processing technology is available on the board itself? Who supplies those system on chips?
So there are different silicon vendors like NXP, like Intel, like TI, like AMD, and we are in very close relationships to them. So we have the chance to get the first processors in a very early step, in a prototype step, to test them in our labs, to develop it to a very professional embedded computer.
Mm-hmm. Now, one of the applications you're showing here shows that capability. We've got a carrier board and we've got your compute module showing an artificial intelligence with automated optical inspection. Can you explain a little bit more about the demo that's working here?
Yeah, so this is one of the trends, to integrate the AI capability to the edge, and not to have it as a separate chip on the board. So I'm showing you an example where the AI inference possibility, the neural processor units, the NPUs, are directly in the chip of the processor, and which gives the possibility that the general 4-core processor here can do his general computing jobs, and the vision part, the neural processing unit, the detection part is only running on the units of the neural processor units. So the performance for this part in this demonstration is not working on the processor, though the processor can do his normal computing jobs.
So I guess also with the carrier board and the processing module construction, that gives your customers the opportunity to maybe upgrade to a new processor as new products come onto the market.
Yes, exactly. So if it started maybe some years ago with a first processor version, from this example from NXP, from the IMX8 family, he could switch now very easily on his same carrier design to a later version of the IMX8 family, for example on the IMX8M Plus version, to have now this NPU integration for better performance support at the edge.
And one of the other challenges that a lot of our Elektor readers have, especially those in the maker space, and we also work a lot with startups, is that they develop something maybe on a Raspberry Pi, a powerful Linux-based processing platform, but at some point they want to industrialize that. How does congatec help them to move from that prototyping phase into something that has long-term longevity of supply and is also robust?
Yeah, so this is very trendy area and very, very exciting area, because the young makers and the startups, they have these fancy, good, interesting ideas, which the classical industrial big companies don't do immediately. And so they have a chance now, after testing with maker boards like the Raspberry, the Wooseberry, Arduino and more. You can realize in the first communication with them that now they were testing and they have a final decision, and now they got the investment, and now they need a hardware solution on a high quality level to have a hardware solution for the next 10 years in this project, and now they need to get serious. And we have starter kits. We have starter kits where you can get this carrier board, you can get this cooling solution and this smart module in a setup with camera that they can immediately go on after Raspberry testing, in a serious testing, again in the lab with our hardware, because we are supplying this for 5 to 10 years or even longer, if we switch again to a newer computer module version. And they are very happy to have a supporter now in a longevity way.
Precisely. Super. Well, thank you very much for your time and explaining all the details of these standardized modular computing solutions, and have a great show.
Thank you for coming up, and now we can have a good fresh juice if you want.
That'd be great. Thank you.
Thanks too. Pleasure.